Hello, my super chemist out in King William. What I'd like to talk to you a little bit right now is called percent error. And if you look in your math unit notes and you scroll all the way to the bottom, you're going to come across this page here. Percent error is really important because as a super chemist, we're going to be talking about lab work and we're going to be talking about data. Okay? And it's important that you can quantify how much error is in your data. And it's okay to have error. We have human error. We have error because of the technology we use. There's all sorts of error, but we just want to know how much of it did we have in a certain lab? How secure are we with our conclusions to labs? Percent error is super duper easy, okay? And you guys are already really good with math, so this is going to be a piece of cake for you. When you look at the formula for percent error, here it is. You notice that there are some bars on the end. Because you are super math students too, you know that that means absolute value. And that means whatever answer you get is going to be positive. So if I plug and chug all this in my calculator and I get a negative number, I'm going to make it positive because I saw these absolute value bars here. So that's not going to give me the heebie-jeebies, okay? What's your data? What did you get? You did a lab. What's your number there? You went and measured something. It was 6 grams when you tried to measure it. 6 grams goes there. I tell you it should have been 7 grams. So that's the accepted value. The 7 would go there and there. Because it's a percentage, you always have to multiply by 100. So that's where that 100 comes from. So let's go ahead and do the example in your notes, and then you guys can just dive into that percent error worksheet that's also attached after this in Schoology and have a little fun with it, okay? So looking at this last slide on Schoology, in your math unit notes, it says, in a lab experiment, you find the density of aluminum to be 3.14 grams per milliliter. That's what you found, okay? The accepted value for the density is 2.7. That's the accepted value. That's what it really is. So that's where those numbers are going to go. What is your percent error? Now, I will tell you on a test, I'm going to expect you to have this formula memorized. I don't think that's a big deal. You guys are all smart kids. Should be a piece of cake for you. So let's plug some numbers in. I do my absolute value bar. Your answer, your data in this problem says that it's 3.14. So that's where that's going to go. Minus the accepted value. In this problem, the accepted value was 2.7. So 2.70 over 2.70 times 100. And my little super chemist brain, how I remember this is what you get minus what you should have gotten over what you should have gotten times 100. And then when you plug and chug this into your super chemist calculator, you should get an answer that's close to 16%. And that's all percent error is. It's one of the easier things we do all year. We will be doing it all year because as we do labs, we'll want to quantify how much error there was in our lab. And don't let that give you the heebie-jeebies. It just is what it is sometimes. Okay? I hope you guys are having a great day at home. I miss seeing your smiling faces. I can't wait to see you in class again. Take care, guys, and be good. Bye.